Hello children, how are you? Today our topic of discussion will be a second type of transport system that is present in our body. What is that? Can you guess? Yeah, that is lymphatic system. We have studied about circulatory system. Now we are studying about lymphatic system in our videos.
Lymphatic system. The main objective of this video is to learn the structure and function of human lymphatic system, which is distributed in our entire body just like blood vessels are distributed. This is the second type of transport system that is present in our body. And the main purpose of lymphatic system is to keep the body's fluids balanced. Second function is to fight against infectious diseases that occur in our body, and third function is to work in coordination with circulatory system. Just like the blood vessels are distributed in our body, lymphatic vessels are also distributed in our body, which reach each and every tissue in our body. If you take a particular tissue in our body, we can see there is a distribution of blood vessels. The red ones are the arteries, arterioles, and the blue ones are veins and venules. The green one is the lymphatic vessels that are distributed in the tissues. And the blood vessels that are distributed in our body has the main role of distribution of nutrients throughout our body. So wherever it is, in whichever tissue it is, it distributes the nutrients into that particular tissue. And the tissue absorbs all the nutrients that are present inside that food material and returns whatever remaining fluid that is present in between the tissue, that is returned back into blood vessel, leaving some amount of this fluid in between the tissues in the interstitial spaces of the tissue. And this liquid that remains back is called as lymph. It consists of white blood cells, platelets, but red blood cells are absent. This lymph returns back into lymphatic capillaries that are distributed in the tissues. Lymphatic capillaries are the blind-ended tubes. You say blind-ended tubes because it is ending abruptly. It is not having any connection to anything else. The lymphatic capillaries are ending of the lymphatic system, which is having minute pores that help in entry of the leftover tissue fluid in the tissues into the small particles of tissue fluid that are left over, enter into the lymphatic capillaries through the small pores that are present in the lymph capillaries, which allows many of the substances that are present inside the tissue fluid to enter into the lymphatic system. All the particles, all the cells, platelets that are present, white blood cells, enter into this lymphatic system and they make their way into the lymphatic vessels. Lymphatic capillaries join together to form a little larger blood vessels called as lymphatic vessels. These are all lymphatic vessels that are present in the body, which join together to form a lymphatic duct, which fuses with the blood vessels veins. Okay. In the lymphatic system, you can see some round ball-like structures which are distributed in entire body in different regions, near armpits, in the groin region, near the neck region, in the elbow region, which are called as lymph nodes. Main purpose of lymph nodes is to produce lymphocytes which help in elimination of infectious material in our body and thus prevents the infections. The distribution of lymphatic vessels and capillaries is seen in entire body, We'll take the example of digestive system. For example, the digestive system, when we discussed, I said you that in the microvilli of the digestive system, there are distribution of blood vessels and also the distribution of lacteals. And I also said you that lacteals absorb fatty acids and they help in transport of fats into the circulatory system. So this not only in the digestive system, in all the organs of our body, we can see that lymph capillaries join to form lymphatic vessels and lymphatic vessels join to form lymphatic ducts. Lymph nodes are the regions where lymphocytes and monocytes are produced and they help in fighting against diseases. All the tissue fluid that is collected from each and every tissue flows in this lymphatic capillaries to lymphatic vessels to lymphatic duct, and finally it fuses with the veins near the shoulder region. It fuses with the veins and help in distribution of this tissue fluid into the blood. In this way, it helps in fluid balance in our body. There is no fluid left over in any region because of the presence of lymphatic system. And these lymph nodes, I said you, they are present in the neck region, in the armpits region, in the groin region, near the walls of intestine. They have main role of protecting against diseases by production of lymphocytes and monocytes. These are nearly 600 to 700 lymph nodes distributed in all these regions of our body. The main purpose of this lymph nodes is to produce lymphatic system. I can say you the examples are tonsils, which are seen near the neck region of the this is nothing but the lymphatic node of the neck region. So we learned that the lymphatic system helps in assist in the circulation of body fluids and helps to defend the body against the disease causing agents. What happens if this does not happen? If the lymph does not drain back into the blood, what happens? We know that the blood consists of 60% of water, and when blood is distributing nutrients to the entire body parts in different regions, what happens is the water gets accumulated inside the cells, and this liquid that is accumulated between the cells is called as lymph, I told you already, and this needs to enter back into veins through lymphatic system. If this extra fluid is not removed, it gets accumulated inside the cells. See, in our blood circulatory system, we have an organ called heart that applies pressure in the blood vessels and helps in distribution of nutrients in the body. But in lymphatic system, there is nothing like that to pump the blood into the lymphatic capillaries, because of which what happens is some external pressure is required for allowing this fluid to enter into the lymph capillaries. Unlike those, the arteries, the fluid from the arteries which comes out because of the arterial pressure, here we need to apply pressure on our muscles to make the fluid enter into the lymphatic capillaries. If that does not happen, what happens? The lymphatic system does not take the liquid from the tissues, and as a result what happens is the liquid gradually gets accumulated inside the various regions of our body, and this lymphatic fluid leads to a swelling of various parts of our body. So one thing I wanted to say is lymph enters into the lymphatic system only uh, when we squeeze the muscles. During movement our muscles contract and relax, only then the lymphatic fluid enters into the lymphatic system. If we do not do that, what happens? If you sit without any movement of the body for long hours, it leads to swelling of hands and legs. This water gets accumulated in various parts of the body. Especially you can see this in older people. Their muscle activity usually is less because of various reasons. They do not prefer to move, and usually during long bus journeys when we do not move, in elderly people it is seen that this liquid gets accumulated in the regions of legs, hands, other areas, because of which swelling occurs in hands and legs. You can even see that by pressing the fingers a pit is formed. This swelling of various parts of the body is a condition called as edema. Edema is the accumulation of excess fluids in the body because of lack of entry of lymphatic fluid back into the venous system through lymphatic uh, system.
Hope you understood what is lymphatic system. Now we'll be studying about blood pressure and how to measure the blood pressure also.
One of the interesting facts about the blood vessels is that if you line all the blood vessels that are present in our body, they form about a long chain of 95,000 kilometers long chain is formed, which can filter about 7,500 liters of blood per day. We know that we have only 4 to 5 liters of blood in our body, but repeated cycles filters 1,500 liters of blood in our body. In our blood, oxygen is present, glucose is present, amino acids, various substances are present in our blood, which flow inside the blood vessels. The blood flowing in the blood vessels, it exerts some pressure on the walls of the blood vessels. This pressure is called as blood pressure. And this blood pressure keeps on rising and falling. When the heart is contracting, the highest blood pressure is exerted on blood vessels, which is called as systolic pressure. And when heart is in a relaxed position called as diastole, the heart exerts a very less pressure on the blood vessels, and this is called as diastolic pressure. The systolic pressure is between 90 to 120 mm of Hg, and this is denoted as numerator when we record the BP. Diastolic pressure is from 60 to 80 mm of Hg, and this is recorded as denominator when you measure the BP, and it is noted as 120 by Hg is a normal BP. Usually it is noted at the arm region because it is very close to heart, and immediately when the heart comes, the pressure can be easily recorded. And when the blood is returning to heart also, veins are having very less pressure. That is why it is very convenient to record near the hand to maintain standard needs, or else in different parts of the body the blood pressure is different. And one thing about blood pressure is if you eat excess of salt, what happens is salt causes water retention and increases the amount of blood, and it causes excess pressure on the blood vessels. Even when you are stressed, some of the hormones called as epinephrine are released into the blood, and it is causing some stress on the blood vessels. The blood vessels get dilated because of the stress, and it leads to increase in blood pressure. So this condition should be avoided to avoid the blood pressure. If this condition continues to occur on the elastic fibers of the blood vessels, it can lead to various kinds of diseases, and the raised BP, hypertension may occur, and it is recorded to be 140 of systolic pressure by 90 of diastolic pressure is recorded as high BP. If the blood pressure is below 60 by 100, then it is said to be low pressure. We have an instrument called sphygmomanometer for measuring the blood pressure. Let us study about the instrument called sphygmomanometer. In this sphygmomanometer, we definitely need a stethoscope also to measure blood pressure. In this, there is an air bag that is present, and it is covered by a cloth called as Lymphatic cuff. And this air bag is connected to two tube-like structures. The larger tube is connected to manometer and the smaller tube is connected to an air bulb. This air bulb is having a valve to allow the air that enters into this air bag. Sometimes it needs to be released. And to measure this blood pressure, manometer has mercury in the center, and on the side there are readings to measure the blood pressure. So we can understand the BP of the person based on the rise of this mercury and the readings that are present adjacent to this rise of mercury level. When you are measuring the blood pressure, the airbag should be wrapped over the elbow of a person. Before that, make sure that the person whose blood pressure is being measured should be allowed to rest for some time. Maybe because of hurry or because of rushing, there may be a rise in blood pressure. If you allow the person to rest for some time, the person returns to normal position, then the blood pressure can be noted. And no tight clothing should be allowed near that region. Uncover that area and wrap the measuring belt around the elbow region, and here there is a sticker for wrapping this air bag around the hand, and it should not be very tight, it should not be very loose. Normally it should be wrapped around the elbow, and mercury level should be at 0 level. Make sure that mercury is at 0 level. Then we will start compressing the air bulb by putting the valve open, and see what is done when the compression is put over the bulb. So we can measure just by observing the pulse at the wrist of the hand when we are measuring the BP. We need to first what we need to do is we need to start pressing the air bulb, and we can feel that air fills up at the elbow region, which helps in recording of blood pressure. And the mechanism of this noting this blood pressure lies in observing our pulse very carefully. Pulse should be recorded very carefully when you are even compressing the air bulb or when you are releasing it in the both cases. So it's always better to use a stethoscope for measuring this blood pressure near the elbow region. So what should be done is a stethoscope should be placed near the elbow region, and some compression should be applied by using the air bulb. When you press, keep on pressing, the mercury level can be seen that it is raising, and at one situation the palpitations or pulse will not be heard at all from this stethoscope. So gradually at that time we need to start releasing this air slowly by releasing the valve. At one situation the beat sound of pulse is heard very loudly. At that point the systolic pressure is to be recorded. And when you keep on releasing the valve, air releases, and at one situation no sound is heard, and that is recorded as diastole. So this is the method of recording BP by using stethoscope.
Okay children, I hope you understood this topic of blood pressure. Now we will be learning about blood clotting. How does the blood clotting occur in our body?
Whenever you have an wound, you can see that various substances are present in blood helping formation of a clot and prevent the flow of blood. Blood consists of various components like platelets, proteins that help in formation of a blood clot, which helps in preventing of flow out of excess of blood from the body. So in this module we'll be learning how the blood clot formation occurs and how it helps to prevent the blood loss from our body. See, if this blood clot is not found, there is a continuous outflow of blood from the body, which leads to excess loss of blood from our body. To prevent this excess loss, our body has a mechanism called as formation of blood clot. The platelets help in formation of blood clot, which help with the help of various other proteins like fibrinogen and prothrombin, which help in the formation of blood clot. So let us understand the mechanism of blood clot formation through this video, children. We know that in our blood there are various components like WBC, RBC, and platelets. And platelets are very useful components for the formation of this blood clot. Whenever we have an wound, there is a cut in the blood vessel and the collagen of the blood vessel is damaged. In this region, the platelets start accumulating. The platelets help in flow of stopping the flow of the blood and formation of clot. How does it happen is whenever there is a platelet accumulation at the site of injury, a substance called thrombokinase is released at this site, and this thrombokinase acts on proteins that are present in the blood. What are the proteins that help in blood clotting? Prothrombin and fibrinogen. And during this blood clot formation, the thrombokinase, which is released by the platelets, acts on the prothrombin, which is an inactive form, and converts it to an active form of protein called thrombin. In the thrombin form, this protein acts on the second protein called fibrinogen, which is also an inactive form of protein, and it gets activated upon the action of thrombin, and it is converted into fibrin. Fibrinogen is an insoluble form and it is found in the blood as a soluble form. It just is dissolved in the plasma and flows. When thrombin acts over it, it is converted into fibrous-like structure which is insoluble. Now the fibrin elements along with the blood platelets help in formation of the blood clots. These fibrin fibers together with the blood platelets form a clot and prevent the flow of blood to outside. It helps in saving the body's blood also. The fibrin fibers are very tensible. They can pull the skin together by causing a pulling effect on either side of the blood vessel. These are sticky fibers and they get stick to the ends of blood vessels. They prevent the entry of any pathogens and slowly they cause the healing of the blood vessels. When the blood clot is formed, there is no outflowing of blood cells also because this fibrin forms a small mesh-like structure, and this mesh-like structure prevents the exit of blood cells outside, and in this way the clot is formed, and this helps our body from causing any external damage. So the fibrinogen and exposure to outside chemicals makes this fibrin sticky and helps in preventing the formation of blood clot. So the blood clotting factors are platelets and fibrin fibers mainly. They form the blood clot and prevent the flow of blood to outside and prevent the pathogens.
Discovery of blood circulation. The discovery of blood circulation started when Girolamo Fabrici, the scientist who studied about the veins in the legs. When he studied about the veins in legs, he saw that the movement of blood was in one direction. In second direction, that means blood always moved from the direction towards the heart. It never moved away from the heart towards the Earth's gravity. Even it was away against the gravitational force, it moves towards the heart even from the legs. That is because veins have valves. Valves are the structures which open when they allow the blood to flow, and they get stick themselves towards the walls of these veins so that the blood flows. Whenever the blood tries to flow in the reverse direction, these valves are closed and block the flow of the blood in the opposite direction. Because of the presence of these valves only, the direction of blood flow was against the gravitational force, and this was discovered by Girolamo Fabrici. After this discovery, there are many other concepts which are discovered by William Harvey. He is called as the father of blood circulation. Let us see what are the things discovered by him. William Harvey did a lot of things for the discovery of blood circulation. He dissected the hearts of various organisms, including the hearts of dead people, and he identified that similar to the valves that are present in the veins, there are valves between the auricles and ventricles also. Because of presence of these valves, he understood that the blood did not flow from ventricles to auricles even when the ventricles contracted, and he saw at the end of ventricles, at the beginning of aorta also, there are very large valves which prevented the backflow of blood from aorta into the heart. He even understood the role of arteries and veins. He tied off the blood vessels, and he saw that arteries got swollen towards the side of heart and veins got swollen away from the heart. See, when the blood vessels are tied off, he saw that since the arteries help in movement of blood from away from the heart, and blocking of this blood vessel caused the swelling of blood arteries towards the side of the heart. And since the veins help in passage of blood vessels from different parts of body towards heart, and this blood vessels started swelling away from heart, that indicates that veins are trying to push the blood towards heart and arteries are trying to push the blood away from the heart. So from this it was concluded that arteries bring the blood from the heart to all parts of the body, and veins carry the blood from all parts of the body to the heart. He also understood that blood pumped to lungs for oxygenation, and he also saw that there is one greater circulation, that is a circulation of blood inside the body parts, and a circulation of blood that is called as pulmonary circuit, that the blood circulated in the from the heart to the lungs, that is called as lesser circulation. So he understood this double circuit circulation also, but he did not understand what is the connection between this greater circulation and lesser circulation. What happens at that time? Microscopes were not so developed to understand the very small blood vessels which were of size of hair. So he did not understand what happened to blood after it enters lungs or after it enters the body parts, how again this blood was created or what happened to blood. It was not clear at that time. But the discovery of blood capillaries by Marcello Malfighi made it all clear about this exchange of gases near lungs. and also at various parts of the bodies, and these capillaries are found not only in lungs, in different parts of the body also they are found. So the exchange of materials was done at this, and the same blood was returning back. That's why the composition of blood in arteries and veins is different. It is not the new blood that is created, it is actually the same blood with exchange of materials was understood after capillaries were discovered by Marcello Malfi. Okay children, I hope you understood all the topics of today. If you did not understand, you can rewatch it till you understand it, and keep learning children. Happy learning. Bye.